Today, I will share what we learned and also what we observed from our real user in the industry. Some of them may be the top tech giant in this world. I will show some use case and also the technical details about our caching technology, and also put a cache for the big data is hard, but we do see the benefits. Okay, let's start. Okay, so the first section, I will give a little bit of introduction about the data cache and the data locality. I think we all familiar with the data cache. Mostly, we are just use somehow faster, maybe more expensive storage, which can cache your most hot data. But on the other side, if you're talking about the physical position for your caching cluster or caching service, we really want to put your cache to be closer to your computer engine. Because now we have a lot of service which are running maybe on cloud. Maybe you still have some storage on your premise data center, or maybe on the other direction, maybe you are using the storage, the cloud storage like S3, but you want to access your data from your on-premise data center. So if we're talking about the physical distance, it's far away from it. The distance between your computer engine and the storage, maybe it's very far. So we want to put the data is more close to your computer engine. But the thing is, after a couple of technical evolution, we are seeing now the architecture of the big data, we are going to something we call the computer and the storage separation. We are separated the computer and the storage, and also we are more like using the cloud data lake, and also we are using the Kubernetes, which means it will be very difficult to co-locate your data into your computer engine. Because when you're using the HDFS, something like that, it's very easy, to run something like MapReduce or something. We can just run your data compute just on your storage, but now it's more difficult. So as I mentioned, by using this kind of modern technology for big data, we are losing the data locality, and sometimes it might be a big problem. So the first is because of the long distance of the data transfer, you may see the slowness of data transfer. And also, if we're talking about using the cloud storage, the cost of your data cloud storage is based on the API, the number of API call, and on the other side is the egress cost, which means if you want to pull data out from your storage, maybe from another region, maybe from your on-premise data center, it will charge you based on the number of bytes you transferred and also the number of API call you have. But the thing is, if we're talking about the big data, we're talking about analytics workload, we're talking about the machine learning AI workload, the number of this kind of thing will be huge. And the other thing is, just because as I mentioned, we want to separate the storage and the compute, because sometimes we really need more reliability and scalability. So we need to do some data migration. We need to copy or move data all over the world, from the East Coast to the West Coast. So it also costs a lot. Okay. So as I mentioned, we may have data copies. For data copy, you may also have the number of API calls, and you may need to manage or maintain multiple storage and computer engines. It will cost a lot. Okay. Besides the technical complexity, we also have a large amount of data we need to manipulate with today. I just give you a rough number about how many bytes we stored in the cloud, not this year, and the year after next year. And it's really a lot. So we're talking about this kind of data. This might be a hard problem for every data infra or data scientist engineer. So I think that something we can improve is, here's our the number we observed from most of our real user and customer. Only 10% of the data is the hot data. Actually, for many companies, especially for the giant internet companies, the percentage of the hot data is much smaller than this number. That's what we observed from Uber. It's already public data. You can see my previous blog or something. They only the 1% of the data can cover their 50% of the traffic, which means if you can have a cache, we only need 1% of data storage can speed up their 50% of the data transfer, or maybe you can save 50% of data load from the under real storage. Okay, so by sharing this kind of thing, I think we can see some gap between the query engine and also the data. We have a lot of data stored remotely, but we have some query engines maybe in the other region or something. We can see the huge gap here. And so today in today's presentation, I will focus on using, we do have other solutions, but today I will focus on using the cache as the first class solution for this kind of things. Okay, as I mentioned, we will focus on the cache, and here is the top 4 benefits we observed from our customers. Firstly, as we design cache, mostly we are thinking of start from the performance for sure, because the cache is a faster storage. Fetching the data from the cache would be much faster than any other storage like HDFS, like S3. On the other side, as I mentioned, because the cloud storage, there are some costs based on your number of API call and the number of data transfer. If you have a cache, which means the data transfer or the API call will hit your cache first. And also, as I mentioned, only 1% of data is the most hot data can cover maybe 50% of our traffic, which means that at a very small portion or amount of cache, you can save 50% of cost, mostly. And also, not just the performance and the cost, we are seeing by using the cache can save a lot of trouble talking about the network. Because if you set up some network connection between your on-premise data center to a cloud, the bandwidth will be very limited. And if you have a lot of traffic, a lot of requests from on-premise data center, because you may have hundreds of services running there, you can see the stability of this kind of connection may be not as good as you thought. We call it network congestion or something. This how you got some incident, we got some traffic spike, you really will got some trouble sometimes. And also, we are seeing the storage on the storage part, no matter if it's DFS or it's S3, even though they claim that they have 99.99% of availability, but actually it's not always true. If you give them a huge traffic spike or a large amount of data or requests, whatever, it will hammer the name node or the data node, whatever. It will reduce the the availability, stability, and the latency, whatever. Increase the latency of your storage, especially when you got some hot node. So using a cache can mostly save your storage by the traffic spikes. And we start from the performance. Why the cache can reduce the end-to-end latency of your query or your job, just because for most analytics and AI machine learning workload, the pattern is something like, we do some compute, then we know, okay, what kind of data we need, then we load the data from the from under storage, and then we do some further computation, and we do load some extra data. Maybe we load the same data again and again. It depends on how you design your computer engine. So just like the first row, without cache, which means compute I/O, compute I/O, compute I/O, but with the cache, because the hard data it's already in the cache. So after the first time retrieving the remote data, the data will be in the cache. And for the follow compute, it will just load the data from the cache and speed up the I/O operations, so we can see the latency, or we can see the time we spend on the I/O will be much shorter than before. That's how the cache help the performance. And also, I would like to share something we got from the storage provider, S3 and GCS, and also the Azure from Microsoft. We can see for each request, there is a very small amount. In each 1,000 requests, it looks like it's a very small amount of the cost for each API call. But the thing is, we were talking about the analytics and the machine learning workload. Maybe you just have a small query. It can generate thousands or millions of API calls because it will scan millions of files, and for each file, it will give you thousands of calls. And also, if we look into the cost, we can see it's very interesting that for some storage engine, for the metadata operations like a copy, like a list, or maybe some write operation put, also it will cost more than 10 times more than the get, select, the read request. So here is what I just wanted to share is besides the data cache, using a metadata cache, it will also help. It will give you, sometimes it will save you a lot just because the metadata API call is maybe 10 times more expensive than the data API call. Also, on the right side, it's the egress. It's a total data transfer. So you can think about if you have a query, it can scan a table, no matter the Hive table or Iceberg table. It will touch a lot of data files. Each file may be just 500 megabytes or 1 terabyte. It will cost a lot. Okay, so here is because I'm the committer and the TSC from the Presto community. So today I will use Presto as an example, but actually this theory is kind of thing can apply to any other computer engine. The same thing. So if Presto wants to run some query, it will try to fetch the data. It will retrieve the data and the list operations, data transfer operations, something like that. Because as I mentioned, nowadays most computer engine is the storage independent, which means it always fetch the data from remote, just like Presto. So every call will go to the under storage, no matter it's local or it's remote. But by using the cache, so the hard data, the data we use most frequently will just in the cache. So Presto will always, not always, when the cache hit, it will load data from the cache. It can save the cost, and which means we will retrieve much less data from remote. And also we can put the cache more close to Presto for the data locality. If it's the distance is shorter, which means mostly it will got a lower distance. In my following slide, I will share a technology called Alluxio Edge, which we can reuse the local NVMe disk on the Presto node as a local cache, and you can use a local latency to fetch data or to reduce the total latency of your query. I think I already covered that in my previous section. Using cache can highly prevent the network congestion and also offload the storage, because in the previous slide we can see the number of API call, the number of the bytes we transfer, it can be reduced by the cache. Okay, before we go into the technical details or the benefits, I would like to share about the traffic pattern of your analytics and the machine learning workload. I will use the example actually, this one is the real architecture from one of our real open source user. They have multiple data centers. They are running their machine learning pipelines in the multiple regions. In some region, it's more close to their data warehouse. They are doing the data ingestion and the pre-processing. They may prepare their data and ingest them into some time table or iceberg table. And on the other side, the other cluster, because they have a large number of GPU running there, but they cannot make this kind of GPU running on their private data center. So it's remote. So the training cluster, just the column in the middle, they will fetch the training data from the region A. I mean, the region B will fetch the data from region A, because the data pre-processing is running on the region A, and the training is on the region B. And after the training, they have some online serving cluster is also on another region. So the region C. The region C will load the model from the training cluster. The thing is, because we're talking about a large language model, we're talking about some, even those for some recommendation or something, now we have a larger and larger model there. So if you have 1,000 of machine running there, which means you have thousands of inference server, they will fetch the new model at the same time. So it will cause some trouble. So in this case, we are trying to put cache to help them to reduce the latency. Okay, but the difficulty here is we are seeing multiple traffic pattern here. Today, let's just focus about the data ingestion and data processing. So for different file format, maybe you have Parquet, maybe you have ORC, but for some machine learning AI training node, maybe you also have some binaries, like the image, like JPG, like the also maybe text file. It can be anything. So for all of these data formats, they may have very unique traffic pattern. Something like the image, mostly you will see a sequential read, which means you read data from the very beginning to the very end. But for the Parquet, for the structured data, you may see the random read, because for this structured data, you may touch the index, and maybe you will go through the data based on the structure. So maybe you start from very end and seek back to the very beginning. So from the cache, it looks like it's a random read pattern there. Yes, as I mentioned, we are seeing multiple read type of access mode, sequential read, random read, and also the number of files can be very small, can be very big. It's also a challenge to the storage, but I think it's a big challenge to the cache. Okay, then I can introduce a little bit about our Alluxio Edge, the next generation cache for the both data analytics and AI. So as I mentioned, we can use the local disk of the Presto, because for most computer engines, they are not really using their local disk. Mostly they are using their memory as a temporary storage for their intermediate results, because the speed can be much faster than local disk. But if we can use a local disk as a cache layer to cache data from remote, which means can save a lot, right? Mostly the local disk can be faster than the network. Maybe it's not always true, but anyway, we still treat the local NVMe as a much faster storage. So by adding such kind of a cache node into the Presto node, we can have a local cache, and the most hot data will put into the local disk, and we make ourselves to be compatible with Iceberg, Hudi, Data Lake, and Hive tables. We also support the CSV, JSON, and text. We support a lot of the text, the file format here, and also we put a dashboard. I will show the dashboard later. You can have an overview of how your computer engine works, how the data transfer is doing now. And for this kind of technology, we call local cache or Alluxio Edge. have been adopted by many tech giants like Uber, like Beinan, Shopee. Also, the Meta is using something very similar. It's also provided by us. So let's go to a little bit deeper about our edge. So, for most computer engine, they may have a coordinator. They may also have a worker. So mostly the coordinator will fetch the metadata and do some query planning or something, and the worker will deal with the query execution. It will try to load the data from remote. So we put Alluxio Edge cache on both coordinator and the Presto workers. So on the coordinator, it will works like a metadata cache, and on the worker, it may work as a data cache. For the Alluxio Edge cache, as I mentioned, we use the local disk, but probably you may have some concern, maybe that the local disk will be very limited or something. So you can put a second level cache. We are using the same technology, the same cache engine, but it's fully distributed, decentralized. You can deploy another cluster. You can somehow have a limited cache capacity, and then it's your real storage, the source of truth. So which means we have a two-level cache. We can cache both metadata and the data. And for the Presto query or Trino query or Impala query, whatever, the same thing. It will try to check the local cache first, the edge cache. If it's not there, check the secondary cache, the DORA cache. If it's still not there, it will go to the UFS, the HDFS S3. It can save your cost and then improve your query latency. Here is what we observed from the real user. You can see 3 times to 20 times faster. If talking about the end-to-end query latency. If we're talking about the table scan, the number is much bigger than this one. And also, as I mentioned, depends on cache hit rate. If they hit the cache, it will save the cost. So again, if you have a lot of cache, you can save a lot. And also, we can improve reliability because we reduce the data transfer to a remote storage. And by using the edge, our Alluxio cache, there's no code change to your running Presto or Trino or Impala. We do have some advanced version of local cache. That's what we work with the open source community, but that needs some code change. But if we're just talking about the simple cache solution, the Alluxio Edge, there's no code change needed. You just put the jar into the Presto, then it works. It can run anywhere on premise, on cloud, environmental. No matter where you can deploy a Presto or Impala, you can use the Alluxio Edge there. Here's some results. I don't want to go to the much detail. We're just using the TPCDS. You can see for most TPCDS, we can see a lot of improvement. But again, if you're talking about the TPCDS, it's more like computer-heavy queries because most of the daily query will be much simpler than the TPCDS query. So which means you can see a much better result for your daily dashboard or analytics query, I'm sure. And also, by using some technology like a combine or merge your tiny requests into a big one, even for the code rate, even for the data is not in the cache, we still see some good performance gain. So still round one. For the round one, the blue ones are the query with the cache, and the pink one, the red one is the query without the cache. We can see the performance improvement, even though the data is still not in the cache. There's still some performance gain. And here's some of the installation about the running the cache. Super easy. We just need to put our Alluxio client jar into the Presto worker and coordinator. There's a plugin library there. Just put a jar there and change some configuration, and then you can enjoy your cache. For the Impala, for Trino, it's exactly the same thing, but for the Impala, there might be something more, but it is still not big work, no code change at all. And here is the dashboard. We can see, by using the dashboard, you can see how many cache you use, how many cache is still available, and also you can see the cost. Here's for for the on the left column, you can see the number of API calls, like the list, the list data, the data cache, the get request. There is some estimation about the cost we save by using the cache. And on the other side, on the right column, you can see the running status there. That's mostly for the latency, and then sometimes when the storage is down or something, it's really helpful for the troubleshooting. Yeah, I think that's probably everything I want to share today. And here is a book about talking about the price to optimization. I think most ideas can be easily applied to any other computer engine. The author is the Hope from Alluxio, and also me. I'm also from Alluxio. You can scan the QR code to get the free book.